Bonjour tout le monde. Good morning, everyone. The CGS is part of this conference, Canadian Geotechnical Society. I'm the president of the Canadian Geotech Society. And since we're part of this conference, we thought it'd be a good idea to talk about a project which united our countries, a geotechnical project that represented a huge challenge. So today I'm going to talk about the construction of the old St. Clair River Tunnel, which was built in 1890. And if I have a few minutes left, I'll talk about a project of a new tunnel we built 100 years later, when I was young in my career. So my main goal is to remind you of the great engineering achievement that was accomplished by Joseph Hobson 130 years ago, one of our great engineers. I'll also say a few words about challenges, and when people tell you it's impossible to do something, and if you believe it's possible, so stick with it and go for it. Now let's see where our project is. It is located just west of Ontario by the border of Michigan under the St. Clair River Tunnel. Looking at it closer, so we have the old alignment of the old tunnel here that was built 130 years ago, and later on we were asked to do a new tunnel that was built right next to it, just 60 feet away from it. In the late 1800s, it was a dream to have a railway connection between our countries, and everybody tried to do this tunnel really quickly, but it was thought to be very difficult in soft clay. So the contractors and the experts at the time decided to go at it piecemeal, just do a bit of a shaft and sink the shaft below the river level and try to do these little pilot holes, and if that worked, then they would enlarge the shaft, maybe eventually do an open cut and do a full-size railway tunnel. But everything they tried failed miserably. When you're reading the archives on this thing, they were digging a shaft and they had a sudden bottom heave, and the whole bottom would blow up and liquefy, and people would get caught in this deep shaft. Trying these small pilot hole tunnels, even at higher elevation, they had gas explosions, sudden collapses, liquefaction. It was amazing. So the project acquired a really bad reputation. A lot of people lost their lives. So the contractor didn't want to do this anymore. The project was cursed. It was impossible to do. But a railway link was still required. So the president of the railway company said, I'm going to send my best man out there, Joseph Hobson, and they asked him, and Mr. Hobson had done railway bridges, the International Bridge near Buffalo, the Victoria Bridge, whatever he touched was a success. But he didn't want to do this. The Prime Minister, and it's interesting going through the archives, looking at these letters, the Prime Minister begging Mr. Hobson to do this job, and he even visited with him. So he refused, but after some intense pressure, he finally reluctantly accepted to do this, but on his term. So the first thing he did, he had three innovations. The first thing he did, and at the time, for a non-geotechnical engineer, for a bridge engineer, he said, I'm going to have a good stratigraphic profile. So he invested to do 110 borings. He was heavily criticized, almost fired on this job, because he was wasting $5,000 to do all this, 0.02% of a budget for this tunnel. Today, it's up to 2%, 3%, 5%, 10% sometimes. So getting the critical data was really required for him. And he decided to place the tunnel right in between the sand layers and the rock to prevent against gas explosion and to prevent against flooding, despite some deep sand. So he said, I'm going to try to do this. And I'm not going to play around with shafts. I'm going to do the open cuts right away and start with a full-size tunnel right away. This is my idea. Don't stop me. So this is the excavation of the clays. And at first, he started doing these little steep cut, and he wanted to place a shield in there, but it failed miserably. A little steeper cut is ready to roll down his shield for his tunnel, and that they had massive landslide, cutting the whole cut time and time again. Mainly on the Canadian side, the US side was a little easier and sandy embankment. But after a while, he succeeded, and he rolled down his machine with a flat slope. So call that the good old observational technique, adapting to the friction angle and the cohesion of the clay out there. And he installed his tunnel. So that was his third innovation. So we talked about not doing the shaft, doing the open cuts, doing the investigation, and now he created this shield. In the time, they called that the Great Canadian Shield, the Great Hobson Shield. That was based on some work that had been done in New York and also in Great Britain. So let's go through this and see what he was dealing with here. At the face, what we call the plenum in modern earth pressure balance tunneling boring machine, the excavating wheel is 16 workers on 3 decks. Tough work it was. They were dealing with sticky clay. So imagine you're digging sticky snow and you're trying to get rid of the snow and it sticks to your shovel. Sticky clay is the same thing. It was really tough to push that clay off of there. And imagine the problem we had later on with the TBM. The clay flow, so once in a while the face would liquefy. There was no stand-up time sometimes. Water leaks and boulders. Large boulders, when they were pushing the machine against that, the boulders were damaging the shield. Floodgates. You read in the archives, those would close automatically if there was a flood. The story doesn't tell what would happen to the 16 workers out there. So it was a little scary. And then he seemed to be the inventor of the erector arm, which we still see in modern TBM now. So the modern TBM arm would pick up the 13 cast iron segments that he would assemble within the shield itself. And when assembled, then he would push with 24 hydraulic jacks and steer the machine with that. So that was quite a modern machine at the time. But the workers, in order to prevent these clay flow and water flow, they were working under high pressure, 34 PSI, and using mules instead of horses. Hobson discovered that horses were not really good in air pressure, and mules didn't care. So mules were good. The workers were complaining after a 5-minute gate compression, which for Hobson was perceived to be as a waste of time because he didn't feel that himself. Workers felt the bends. They had the bleeding of the mouth, wobbling at the knees. And then they didn't like that. And also they were a little worried about the risk of gas explosion, flooding, and it was too dangerous, and they went on strike. Imagine at the time, went on strike. So Hobson dealt with them and decided that he would give them danger pay, an extra $1. But when they were approaching the water to go under the river, he thought it was too dangerous, and he handed his resignation. He says, I'm going to stop the project, I'm going to kill someone. But his resignation was refused. 13 months later, he started the shield on the Canadian side and the shield on the US side from an open cut. The shield met at 15 foot per day, roughly, and they were about a 1/4 inch off on vertical and horizontal alignment. Absolutely amazing. And it was pretty well on time, but he really busted his budget by $2,000, 0.07%, and he was heavily criticized for that. Imagine today being that close. So this is an artistic rendition of the Scientific American that appeared in 1890. So this is a fantastic achievement. I love talking about this project. This is why I'm here now. And it was recognized as a national civil engineering landmark by the ASCE. So Joseph Hobson, a great engineer. Now we needed to do a new tunnel. Why? Because we have bigger trains, and bigger trains need a bigger hole in the ground. And we went out to do our own investigation. So when this got started, the big VP Finance came to me. He says, Mario, and I was young at the time, we've had all these analysis for the past 20 years saying that it was impossible to do this tunnel in the area, so find another place within 100 miles with better geology. There's no better geology. And I looked at this thing, I looked at the archives, I said, yes, it could be done with modern earth pressure balance TBM. And within a few days, I said, cockily, yes, it can be done, maybe $400 million, instead of $1 billion cost estimate before. Please don't do a bridge there, a tunnel could be done. They got all excited, they said, fine, you spend $2 million on a full feasibility study and report back to me in 3 weeks. I asked all my friends to help me, and they said, no, Mario, you're crazy. You get them all excited, you'll get fired. So nobody wanted to help me. So we did this together, and then you will help me now to do a little bit of risk assessment of what we were dealing with this new tunnel. Well, firstly, we're going right off the bat with this great big machine, a big hole in the ground. We're going under an industrial plant with large gas tank. and it's impossible to avoid settlement, especially at the beginning. And in fact, we did had a couple of meters of settlement in some areas. So we had to deal with that. Then we had to deal with this famous sticky clay. So when you're excavating this with a tunneling boring machine, all the clay gets stuck into the chamber and doesn't get out. So we had to find a solution for that. We thought about having soap, and that worked. Unstable phase. Then flooding. Flooding could come from deep sand pockets that would connect to our tunnel, and also from the lower till. Gravelly till, really permeable with high pressure, even higher than the river. So there was a lot of risk there. And then gas and water pockets, many boulders throughout. And toxic gases that had been stored years ago in deep salt mine that were going up to the surface, very, very dangerous. And we're building all this right next to a tunnel in operation with our big tunnel just right next to it. If something happens, we lose everything. And of course, the landslides at the beginning, the fast-track design build project, so when they got excited, they wanted to have it tomorrow. 260 permits to get, and the First Nations to deal with in this area. And that was all done successfully. And from the time we thought about it to the time we started construction, only a year and a half, everybody said it would be impossible. So at that time, we got the money, the project is capital approved, and all my friends refused to help me. Now, they're positioning themselves, they were ambitious. So I felt like the little guy here, and all these guys were passing me and wanted to have a lead on that project. So I had to defend myself there. So we built this great big tunneling boring machine, and then started doing our tunnel right next to it. So starting right next to a tunnel in operation, and all these slopes weren't stable, we had to deal with this. And as we were digging the new tunnel, it was right next to a train in operation in this old cast iron tunnel that was still in fairly good shape, but a little brittle. And you will feel what we could feel when they all said, Mario, is going to be impossible.
Huron, engineers,
that's good here.
Contracts began to appear in the concrete.
And I see this, and I still have goosebumps. So if you ever have a chance to go through a tunnel breakthrough, especially when it's a tunnel.
4 a.m. on December 8th, Excalibur emerged into the United States, ending a journey that began over a year before and more than a mile away on the other side of the St. Clair River.
So all these guys that told us, geotechnical engineers and the firms that worked with us, it was impossible, in your face, we did it. So that was, that's how I felt saying it here. So to conclude here, both projects were deemed too risky. They all said it was impossible, but when you get your mind to it, you can do this thing. The new one, we had better knowledge, but other challenges to play with. When you have a good idea, don't quit. And at one point, talking to you, the young engineers in here, something feels good in your mind, you think it's going to work, but in your gut, your instinct, you know this will work, and you have to keep pushing hard. Same thing if you see a dangerous situation, and if it doesn't feel good here, that's your instinct talking. Sometimes you can't understand. Follow your instinct. Here, Hobson finally followed his instinct, and despite all the difficulties, he succeeded, and we try to do the same. Persevere despite of criticism. The old tunnel remains a greater achievement. Thank you for listening to me.